Section 5.5, Electron Configurations in the Periodic Table. Up to now, we have written electron configurations using the energy level diagrams. As conformations involve more energy levels, this can become tedious. However, the electron configurations of the element are also related to their position on the periodic table. Different sections or blocks within the periodic table correspond to the S, P, and D and F sublevels. Therefore, we can build the electron configurations of the atoms by reading the periodic table in order of increasing atomic number. Blocks on the periodic table. The S block includes hydrogen and helium, as well as group 1A and 2A. This means that the final 1 or 2 electrons in the elements of the S block are located in the S orbital. The period number indicates the particular S orbital that's being filled, 1s, 2s, and so on. The P block consists of elements in group 3A to group 8A. There are 6 P elements in each because the 3P orbital can hold up to 6 electrons. The period number indicates the particular P sublevel that's filling, 2P, 3P, and so on. The D block. The D block containing the transition elements first appears after calcium, atomic number 20. There are 10 elements in each period of the D block. 5 D orbitals can hold up to 10 electrons. The particular D sublevel is 1 less than the period number. For example, in period number 4, the D block is the 3D sublevel. In period 5, the D block is the 4D sublevel. The F block. The inner transition metals are the 2 rows at the bottom of the periodic table. There are 14 elements of each block because the 7 F orbitals can hold up to 14 electrons. Elements can have atomic numbers higher than 57, lanthanides, have electrons in the 4F block. The particular F level is 2 less than the period number. For example, period 6, the F block is the 4F sublevel. In period 7, the F block is the 5F sublevel. Electron configurations using the periodic table. Now we can write electron configurations using the subblock level on the periodic table. As before, each configuration begins at hydrogen. But as we move across the table from left to right, writing down each sublevel block, we come to until we reach the element for which we are writing the electron configuration. We will show how to write the electron configurations for chlorine from the sublevel blocks of the periodic table in practice problem 5.6. Period 4. Up to period 4, the filling of the sublevels has progressed in order. However, if we look at the sublevel blocks in period 4, we see that 4s sublevel fills before the 3d sublevel. This occurs because the electrons in the 4s sublevel have slightly lower energy than the electrons in the 3d sublevel. This order occurs again in period 5 when the 5s sublevel fills before the 4d sublevel, and again in 6 where 6s fills before 5d. At the beginning of period 4, the electrons in potassium and calcium go into the 4s sublevel. In scandium, the next electron added after the 4s sublevel goes into the 3d block. The 3 block continues to fill until it's complete with 10 electrons at zinc. Once the 3d block is complete, the next 6 electrons, gallium to krypton, go into the 4p block. Some exceptions to sublevel block order. Within the filling of the 3D sublevel, exceptions occur for chromium and copper. In chromium and copper, the 3D sublevel is close to being half-filled or filled sublevel, which is particularly stable. Thus, the electron configuration for chromium has only 1 electron in the 4s and 5 electrons in the 3D sublevel to give the added stability of a half-filled D level. This is shown in the abbreviated orbital diagram for chromium. A similar exception occurs when copper achieves a stable or filled 3D sublevel with 10 electrons and only one electron in the 4s orbital. This is shown in the abbreviated orbital diagram for copper. After the 4s and 3d sublevels are completed, the 4d sublevel fills as expected from gallium to krypton. The noble gases completes period 4. There are also exceptions in filling for the higher d and f electron sublevels, some caused by added stabilities of half-filled shells and others where the cause is not known.